Hello, welcome to Chapter 1, Section 1, Notes over Interval Notation and Set Builder Notation. Now this is a new notation that you haven't seen before, but it's actually not hard to learn, and interval notation is very concise while being descriptive, and it's pretty intuitive. Alright, so in mathematics, a collection of objects is called a set, and you've seen sets before. We've dealt with them in Algebra 1. You can use braces, so that's what those little squigglies are called, to represent a set by listing all of its elements. And sets can be represented as intervals. So on a closed set, or a bounded interval, like we see here in this first set of graphs, right here, we have lots of different options. Now, in this very first one that I'm pointing to now, both endpoints are closed. So they're filled in. That's all that means. If they're closed, they're just filled in. And you've seen that before when you were dealing with inequalities, again, probably in Algebra 1. When that's the case, when it's a closed point, it gets a bracket. So you'll notice here, there are brackets. If it's an open point, like here, then you get parentheses. And that's the basic rule. And that's it. And it's always left to right, or when you're talking about domains, it's bottom to top. But you always read left to right, so that's how you'd write your interval, from left to right. They can have one closed and one open, like on the third one, where it's a bracket and then a parentheses, or it could be open and then closed, where it's a parentheses and then a bracket. Now these are bounded intervals. There's also an unbounded interval. And that's where you start at a point and you go on forever. Or you start from negative infinity and you stop at a point. So that is shown here. Now if you look at the A example, it starts at a point and goes on forever. The top one is closed, the bottom one is open. So the top one has a bracket here, and the bottom one has a parentheses. Now instead of putting, x is greater than or equal to A or x is greater than A, we take our number, we put a comma, and then we use an infinity symbol. Okay, so you use infinity symbols in interval notation. You do not use infinity symbols in inequality notation. As a general rule, we just don't do that. Okay, but you do use them in intervals. And I'll show you more examples of this, but this is what it looks like. If you start from the left and you're going on forever on the left, like it is in this example down here, then you start at negative infinity and you go to your number, right? Again, because you're doing it from left to right, the left is negative infinity, the right is positive infinity, assuming it were to go on forever. Infinities always get parentheses. Now the reason they always get parentheses is because they aren't actually a number. You can't touch infinity. It's not something you can pinpoint. It's a concept that tells you that it's going to keep going. Okay, so because it's not an actual point that you can put a closed circle on, it is a parentheses. Now, let's say you have this last situation, okay, down here, and that wasn't there for no reason. You can go from negative infinity to positive infinity, right? You can have all real numbers. And so the way you would write that is with parentheses, negative infinity, comma, positive infinity, close parentheses. Now, you might notice that the left thing that I wrote isn't very clear. So when you're doing this, you need to make sure it is very clear that that is a parentheses or a bracket, depending on the case. All right, so let me show you some examples. So if I ask you to write something in interval notation, it's very simple. You write the left number, comma, the right number, and then you just have to decide if it's a parentheses or bracket. Now, or equal to means that it's a closed point, so it gets a bracket. And less than, without an or equal to, means that it is an open circle, so it gets a parentheses and we're done. That's how you do that problem. Okay, let's look at B. For B, x is less than negative 2. Well, if it's less than negative 2, there's not actually an endpoint on the left, right? So it goes on forever on the left, which means that we're going from negative infinity to negative 2. Okay, so you put negative infinity, comma, negative 2. Infinities always, always, always get parentheses. And the negative 2, because there's not an or equal to, will also get a parentheses in this particular case. And that's just using an inequality. right? You can also look at a number line like we did in the example, or in the table on the last page. So here on part C, we're going from -1 to 3. So you write -1, comma 3. Very simple. The -1 is open, so it gets a parentheses, and the 3 is closed, so it gets a bracket. Now, sharp corners are important for brackets. Okay, be very clear. If we can't distinguish whether or not that is a parentheses or a bracket, you don't get the credit for it. In part D, we're going from 1 to infinity. Well, the farthest number on the left is 1, so we start at 1, comma. It doesn't stop on the right, so it's going all the way to infinity. The 1 is open, so it gets a parentheses, and infinity always gets a parentheses. Now let's talk about set builder notation. This is what set builder notation looks like, and it's really taking an inequality and sticking it in braces. So if you know how to write an inequality already, it should be very simple to just transfer that into set builder notation. Now the way this reads is you will have a parentheses and x, or whatever letter you're talking about, a bar, and then your inequality, and then your closed braces. Okay? So you say it as the set of all numbers, x. The line is such that, that's what it means. And then you would read the inequality, so x is less than b. Now, if you have an or in there, because there's a space like there is here, you just include that or. Otherwise, you would write the inequality like you would in part A on example 1. Or you'd write it like you see above, right, where it's just less than b, right, whatever the case may be. So, first, let's go ahead and graph, because you are going to have to graph when you're doing this on a number line. So we have to sketch the graph of the set of numbers, x, such that x is less than -2 or x is greater than 0. Well, if x is less than -2, we should probably put 0 and -2 on here. So let's say this is 0 because it's the middle, and then -1, -2. Okay, that's as much labeling as you need. If you'd like to add more, you're welcome to. They're both not underlined. Okay, so neither of them are or equal to, which means that they are both open circles. So I'm going to draw a very clear open circle on both of them. Okay, it's super, super important also if I'm grading a number line that I can tell the difference between an open circle and a closed circle. You are using pencil, so if that means that you need to erase the little center out of the middle, that's fine. Or if you need to do it again, that's fine. Just make it very, very clear. Now, if x is less than -2, that means everything is going to the left of it. And if it's greater than 0, it's going to the right. And that's it. Now let's write these in set builder notation. So the set of numbers less than 3. Well, I'm going to call the set of numbers x. So I have a brace, x, such that x is less than 3. Well, I would write that as x is less than 3. And there you go. That's it. For part B, I have an interval. They gave me an interval that I need to basically translate into set builder notation. So again, I'm going to use the variable x, such that. Now this time I have a closed interval, a bounded interval. So I'm going from 3 to 5. Right, so x is between 3 and 5. And one of those is a bracket, so one of them gets an underline. It's the 3. There you go, and we're done. Those are your notes. Make sure you write everything down, and make sure, if it wasn't already, your page is set up in Cornell style, and that you do your essential question at the top, your questions on the side, and your summary at the bottom.